So when you have division, all of the ones that I give you will be written like this. It won't be a crossed. So you will get it on top of each other in fraction form. The first thing you want to do is see if you can reduce. And so you have 15 over 40. Can you reduce it? Yes, by what? 5. And so you're going to divide the top and the bottom by that 5, right? And what are you going to get? Square root of 3 over square root of 8. So then the next thing you want to do is, can either one of those simplify within themselves, right? The 3 is prime. It cannot simplify. What about the 8? Yeah, so 8 can simplify. So if I'm going to write my 8 out, 2 and 4, 2 and 2, my index is 2. So I'm looking for things that group up. That groups up. This does not. So I'm going to rewrite this fraction as the square root of 3 over 2 on the outside, 2 on the inside. Once you have reduced the fraction and simplified your radicals as much as you can, the last thing you want to make sure is that you do not have a radical in the denominator. In this case, we do have a radical in the denominator. So we need to multiply the top and the bottom by that radical. So we're going to say the square root of 2 down here, the square root of 2 up here. Remember, you multiply inside, inside, outside, outside. All right? So on the top, we have the square root of 3 times the square root of 2, which is going to give us the square root of 6. Okay? On the bottom, we already have a 2 on the outside. And then when I multiply the square root of 2 times the square root of 2, it just gets rid of the radical. It becomes the square root of 4, which is just 2. So basically, you just get rid of the radical, and we just have a 2 there. And of course, we can multiply 2 and 2. So we have the square root of 6 over 4. You cannot reduce the 6 and the 4. Why not? The 6 is on the inside of the radical. The 4 is on the outside of the radical. So this is as simple as this is going to get. I don't want a triangle. Let's make it a square. So square root of 6 over 4 is my answer. So when I get something like this, I am going to look at two things before I start dealing with the radicals themselves. I'm going to look if the outside numbers can reduce with each other, and then I'm going to look to see if the inside numbers can reduce with each other. So the outside numbers are 2 over 3. Those cannot reduce, all right? The inside numbers, however, are 4 over 28. These can reduce. What goes into both 4 and into 28? Yeah, 4 does. So I'm going to divide the top and the bottom by 4. So for this one, I'm going to leave the 2 on the outside. 4 divided by 4 gives me the square root of 1. Down here, I'm going to leave the 3 on the outside. 28 divided by 4 gives me the square root of what? 7. 1 actually has a perfect root, right? What is this? The square root of 1? It's just 1. So on top, I really just have 2 times 1. And on bottom, I have 3 times the square root of 7. So I end up with 2 over 3 times the square root of 7. So right now, my fractions are reduced as much as they can, and my radicals are reduced as much as they can. I just need to get the radical out of the bottom. So I am going to multiply the top and the bottom by that 7. I have a 2 on the outside, a 7 on the inside. I can't multiply those. So my numerator is just 2 square root of 7. On the bottom, I have a 3 on the outside. And when I multiply the square root of 7 times the square root of 7, that becomes just a 7. Again, my numerator is as simple as it gets. So my numerator stays 2 times the square root of 7. My denominator becomes 21. And that is as much as I can do with that one. So that is my answer, 2 square root of 7 over 21. All right. So 8 over 5, I'm going to check that first. I'm going to look here and say, does this reduce? It does not. So 8 over 5 does not reduce. I am just going to leave that alone. My 8 is going to stay on top. My 5 is going to stay on bottom. All right. Then I am going to look at my numbers, 10, 35. Those are both inside. All right. And so what comes out of 10 and 35? 5. 10 divided by 5 is 2. 35 divided by 5 is 7. All right. Then I'm going to look at each variable individually. I'm going to start with my A's. I have 3 A's on top and 2 A's on bottom. When you divide, you subtract those, right? So it's going to be wherever I have the most of them, right? So I'm going to take 2 out of both of them, and what am I going to end up with? Just 1A on top, okay? Correct. So I have 3 A's on top, and I have 2 A's on bottom. I can cancel one at a time. It ends up being subtraction. So I end up with just 1A left on the top. So now I look at my B's. I have 4 B's on top and 3 B's on bottom. What am I going to end up with? 1 B on top. All right. Does everybody see? All right. So what I end up with when that's, I'm going to write it just a little neater. I still have the 8 on the outside. I have the 2AB on the inside in the numerator, 5 on the outside, and 7 on the inside in the numerator. This is as simple as my fractions can get and as simple as my individual radicals can get, okay? I say that because if I had been left with b squared on top, I could actually pull that out, right? Does that make sense? So if even your variables can reduce again at this point, then go ahead and reduce them out before you do any multiplication. So at this point, the only thing I need to do is get the radical out of the denominator. All right, so to get rid of the 7, I am going to multiply the top and the bottom by the square root of 7. All right. On the top, I still have an 8 on the outside. I have a 2 times a 7 here. So I have 14. My A and B do not change. They just stay exactly the way they are. On the bottom, I have this 5 on the outside. All right. This square root of 7 times square root of 7, remember that's square root of 49, which becomes just 7 with no radical. So I have 5 times 7 on the bottom. And so my final answer for this one is going to be 8 square root of 14AB. All of that is inside the radical. And on the bottom, I have 35. And yes, you do want to check. Can my 8 reduce with my 35? No, it cannot, so I am done. This is my answer here. So with addition and subtraction, you have to have like radicals. Like radicals mean that you have the same index, which I think for your whole quiz, I'm just doing square roots at this point, so you're probably good on that. But same index, and you have to have the same number inside the radical, okay? Same number inside the radical. So this first one, they just handed it to you, right? Once you have like radicals and like index, then you just add or subtract the coefficients, the numbers that's on the outside. So the only thing you have to worry about is doing your rules for positives and negatives, all right? So here I am going to say -3 minus 3. What is -3 minus 3? It is -6. So I have -6. My square root of 5 does not change. That is my answer. -6 square root of 5. All right, for this one, you just have 3 of them. If they are alike, you can add and subtract them. If they are not alike, you cannot, all right? So your answers may not always be nice and condensed and pretty with like one number. You may have multiple things. In this case, they actually already give you like ones as well. If I were to factor this, it's just 2 and 3. Square root of 6 is as small as it can get because nothing pairs up. So I'm just going to say which of these are alike. Well, this is alike and this is alike. So those are the ones I'm going to combine. And I'm going to look at those coefficients, right? I have -1, right? So if you do not see a coefficient, it is a 1, -1, and +3. So what do I get with -1 and +3? Yeah, it's just going to be 2. So I have 2 square root of 6, and then this right here cannot combine with anything. And since that cannot combine with anything, it stays the same. If it stays the same, use whatever sign is in front of it. It's a minus in front of it. It's a -2 square root of 2 here. All right, so you will also have some like this. These are not alike. So your first thought is, well, I cannot add or subtract them the way they are. But you also have something that's not simplified. That 80 is not the radical in simplest form. And so the 5 is in simplest form. It's already prime. but the 80 is not. And so with the 80, you are going to want to factor and get that in simplest form. All right. And we're looking for an index of 2. So if it groups up in 2s, we can pull it out. We're going to leave this negative 2 square root of 5 alone. Right? And then over here, we can pull out a 2 for that. We can pull out a 2 for that. And then we have a 5 that is left in the root. All right. You do want to simplify them first. So I have negative 2 square root of 5 here, minus, and I have this 2 times 2 right there. So I have a 4 square root of 5 here. And at this point, we now have like radicals, and I can do exactly what I did on my first problem on this page. I can look at my coefficients, and I can say, how am I going to add those up? Well, I have negative 2 here. It's hard to read. Negative 2 minus 4. All right. What's negative 2 minus 4? Negative 6. And so my coefficient here is going to be negative 6. And my square root of 5 does not change. Negative 6 square root of 5 is my final answer there.